Light has long been a fascination of scientists, but it travels so fast that it was very difficult to study. Isaac Newton, the brilliant English physicist who lived in the 17th century, believed that light was made up of extremely small particles, but he could not explain how it traveled. Others believed that light was energy that traveled in waves, but they could not figure out how light waves could travel through space. By that time, quite a lot was known about sound, and it was felt that all energy needed a medium in which to travel. Scientists concluded that space had to be filled with some type of matter they called ether, which acted as the medium for light. In 1873, James Clerk Maxwell, a British physicist, resolved most of these problems. Maxwell developed equations based on the earlier work of Michael Faraday, who had demonstrated the link between electric fields and magnetic fields. The oscillations, or movements back and forth of electric charges, generate electromagnetic waves of energy, which propagate as transverse waves. Maxwell's calculations of the velocity of these waves match the speed of light, and led him to predict that light is an electromagnetic wave. Since electric and magnetic fields can exist in both a material substance and a vacuum, these waves do not require a medium and can travel through air, water, or the vacuum of space. Once that was understood, physicists abandoned the notion of ether. If we could see them, transverse waves would look something like the waves in this rope, or the ripples on the surface of a pond. This animation of an electromagnetic wave shows both the electrical and magnetic component of the wave. Note the two parts of the waves are at right angles to each other. Maxwell believed that electromagnetic waves were only energy, but it is now known that they are both waves of energy and particles called photons. This is called the wave-particle duality. All electromagnetic waves travel through space at the speed of light. Our greatest source of electromagnetic waves is the sun, but it is also the energy in radio and television waves, electric lights, the light emitted from fire, the atoms that make up matter, and much more. Electromagnetic waves are everywhere in our universe.